Hello everyone, welcome to the latest episode of Coffeecontalk. Today we have the pleasure of inviting Mr. Dev Kakde with us. Mr. Dev Kakde is a statistician with education and expertise in manufacturing and transportation. He has also contributed to the original research in machine learning theory, quality control and prognostics. He is also an ASQ certified reliability engineer and has a knack for solving engineering problems using statistics and machine learning techniques. Currently, he is working as a principal research statistician and developer with SAS Analytics. Sir, our first question for you is, nowadays we hear a lot about how data is the new oil, as in how valuable yet useless it is in its unprocessed form. So with your background in manufacturing and transportation, we would love to hear your insights on the importance of data analytics in this sector.
Okay, so you are right, data needs, whenever you want to do some analysis, you have to process the data. So that is a very important step in any kind of analysis. I would say that takes a majority of amount of time, that how you make your data ready for analysis purpose. Okay? That is a very important step. And then there are many things you have to do. Like, for example, you have to, many times you may have some missing values in your data, right? So what you do about your missing values? Then there may be some kind of aggregation you may have to do. So for example, your data is daily, but you do analysis on a monthly basis. So how do you aggregate? Right? So for example, if you are producing in a factory, right? If you are producing certain parts every day, that's the data you have, but you want to analyze, what are my monthly sales? So the processing will be here, summation of all the data you are having. So that's one thing. And then if you have missing data from some months or some days, how do you interpolate or use some other techniques to transform the data, right? That's another part. Then sometimes you have to do transformations like log transformation. Sometimes you have to do. So there are different steps you may have to take to make your data ready for analysis. So in manufacturing, transportation industries, there are many different types of analysis you can do. Manufacturing, there are a lot of problems related to product quality, productivity, energy consumptions, right? Those can be solved using analytics. What is happening nowadays is that because of advances in sensor technology, you have a lot of real-time data, many sensors, or which are related to a certain manufacturing process. So that data can be used, and it can be used to do some real-time predictions, which can be useful. For example, you can do real-time predictions about the quality of a product based on the measurements you take on your machine. So that's it. And also in transportation, also what happens is that if you think of a truck, right, for example, or a locomotive, you have to make sure that these vehicles, they do not fail when they are operating. So if the truck is going from one town to another, taking some goods, right, it's essential that there is no breakdown. So for that, it is essential to have a model which can predict when you are most likely to have failure after how many miles or how many days, and develop some model to do periodic maintenance based on it. So this is called as condition-based maintenance. Well, condition-based maintenance as well as time-based or usage-based maintenance. So the earlier example I gave you, where you have to do based on miles, is usage-based maintenance. or it is also called as preventive maintenance. But there is also predictive maintenance, where you also continuously monitor what is the condition of your vehicle. Right? That may be related to the engine temperature, or how much load you are carrying. And then you develop an estimate of how much wear and tear is happening in your vehicle. So all those things are very getting a lot of traction nowadays. And so these are some of the examples I can give you, like manufacturing related to quality, productivity, how one can reduce energy consumption, CO2 emissions. These are some examples. In transportation, what comes to my mind is when to do maintenance on a truck or a locomotive, as well as at what age you may want to retire a vehicle. So then you may also want to do analysis at a fleet level. So if a truck company has 30 trucks, 40 trucks, right? They may want to analyze, okay, why certain trucks are failing more compared to others. So, for example, if truck is traveling in Rajasthan, there is very high temperature, there may be sand particles in the air, right, near the desert areas. So that may lead to more failures. So you may want to analyze the data in that dimension also, that where that particular truck is traveling, does it have any correlation with failure patterns? So there are a lot of scopes. There is a lot of scope to do different type of analysis. It requires some creativity and talking with your business team, trying to identify their problems and then working to come up with a solution.
Yeah, so as you mentioned many case studies earlier, you have a knack for solving engineering problems using statisticals and MI techniques. So would you like to tell us about some of your projects?
So, I will tell you some of the typical projects one can do in this area, where engineering knowledge can be used. So what happens is nowadays, as I said, because of sensor data, right? What is happening nowadays is that you can get the actual status of many engineering assets or engineering. When I say engineering assets, you can think of it as a machinery or some equipment which is used in a factory, right? So if you think of a machinery, specific equipment. So, and as I said before, right, the objective is to minimize the power consumption or increase the uptime of such equipment. Right? So those are our objectives for doing an analysis. So what happens is that nowadays it's possible to know how that particular machine is operating in real time, because you are measuring a lot of things. So that technology for measuring important parameters of a machine, right? So for example, RPM, right? Rotations per minute, or some temperature in the machine, right? Like if you think about an engine, right? So what is the temperature of my engine? What is the RPM of my truck? So those things, they can be measured. And prior to this revolution in sensor technology, this was not always possible. Now, in addition to sensor technology, there are other enabling technology features, which are leading this monitoring to be possible. So, for example, the internet technology, right? It is now very easy to collect this data and transfer this data over wireless network, right? So you all know that all of you use cell phones, right? And you know how good the wireless network is nowadays. So that also is being used in these applications. So you sense something, you measure it, and you transfer that data, right? So what is happening now? It's very easy to get a digital equivalent of a physical equipment. So what I mean by that is that anytime you can take a look at your equipment by just looking at these sensor values. Okay, what is my temperature? What is my RPM? What is the pressure value? So all these measurements are possible. Now, this was not the case like 10 years or 20 years back, that you can get a real-time picture at such a large scale. There were some assets which were fitted with these sensors, and it was possible, but that was more restricted to some very high value assets, not for the spread. The use was not this widespread, I would say. So what is happening? So with this data, you can create what is nowadays called a digital twin. Okay? So you should look up what is a digital twin. Try to read about it. It's a very interesting concept. So what does a digital twin means is that you have a twin means what? It is just that physical twin, right? It is just like the physical equivalent, right? So they two are, you can think of twin siblings, right? So exactly same thing is happening. What is happening in the physical asset is happening in a digital asset. Now, this digital asset is nothing but these measurements. Then you can develop some models based on this sensor data, and again you can come up with some models which will tell you whether my equipment is behaving as I expect it to behave, or there are some anomalies, or there are some problems in my equipment. So when you want to do such analysis, right, whether it's behaving normally, whether there are any anomalies, that's when you need statistical and machine learning techniques to analyze such data. So that's where there are a lot of applications. This is a very emerging field now. There are different objectives, like I told you, right? Equipment uptime, product quality is one, to reduce CO2 emissions and things
like that. AI is increasingly being used in making business decisions. So to what extent do you think it can replace human efforts?
Okay. So there are two aspects to it. One is when you say decision, right? So the AI model will take some data and whatever objective function you define, that okay, this is the reason I'm doing my analysis. So you may want to do some prediction, right? So for example, you may want to come up with a model to find out, okay, so I have 50 machines and I have developed a model which will tell me that, okay, this particular machine will fail in these many days, okay? Some kind of reliability model. So the model, if you have good quality data and all the possible data which is required to come up with such model, if that is available, then you can come up with a good model, provided you have a lot of history and different scenarios under which something can go wrong. If you have all the data, you can come up with a model. Now, once you get model results, right, somebody still have to execute those results. So if I tell that, okay, this machine is going to fail, our technician still has to go there and fix that machine. So you can think of a lot of these models as something which helps in decision making, but we still need a human intervention to execute what decision is being recommended by them. So many times a lot of experience of the operator or person who is fixing that machine is also very important. And this can make some recommendation, and over time, those recommendations become better and better as we get feedback from the humans. So that is another aspect, that whenever a model makes a recommendation, some human has to look at that recommendation and give feedback. Because you can say that, okay, a model will tell that, okay, it will rain, right? But what if it did not rain? Now human has to look at it and give that feedback. So there are efforts to make the models more and more sophisticated, but I don't see humans going out of picture, because first reason is that those actions have to be executed by humans, because whether what happened after taking that action, whether that action was necessary or not. So what happens when you develop a model, right, and you execute that model? Now you come up with certain recommendations. So the model evaluation phase, right? So I tell that, okay, this event will happen. So did that event actually happen? Now I tell that event will happen, but it did not happen. And I said that event did not happen, and it did happen. I said that event will not happen, and it did not happen. So this is something called as, like, if you look up, it is called as a model evaluation, in which you classify a prediction based on whether it's a true positive, true negative, false negative, or false positive. So many times, at least in manufacturing and some of the use cases I told you about transportation, the human feedback is necessary, that humans will actually do the required action. And then, so that would be my take.
Question is, recently the FTC has issued a report warning, saying that AI solutions can be inaccurate, biased, and discriminatory by design, and hence should not be relied on as policy solution. So what is your opinion about that? And one more case study about this is, there have also been some controversies, like the one involving Microsoft. Their AI chatbot there, which was an experiment in conversational understanding, was coming up with his own version of hateful speech after absorbing inputs of that kind. So now machines certainly don't think themselves. They simply process according to what the input is. So who is responsible, and how can we regulate what input goes into them and has these machines, and how the progress been made on that front?
So it is very important that when you create your data set, right, for training a model. Like I will come to the first question where when you talk about model not being fair, certain subpopulations. So one has to make sure that model is the data which you are using for building your model is well represented. So sometimes what happens is that certain dominant class, right? It may lead to model behave in a certain way. So what I mean by that is that all the predictions will be based on the examples, which the model sees for one particular class. So if you want a generic model across different subpopulations, we have to make sure that all these subpopulations are adequately represented in your training data. So that is very important. And one has to make sure that the model is very well trained and it generalizes well. So what I mean by generalizes well is that on a independent data which was not used for model training, how good it behaves. So that is very important. What I mean is that you have to make sure that before you roll out such projects, right, you have to make sure that you should test it for a good amount of time. Sure that all the edge cases are accounted for, so that we don't have the problems as like you mentioned. So that is very important, that if you have a model, you should make sure that it is properly tested before it goes out in production. When I say in production means people start using it on day-to-day basis. So testing of your algorithms is very important, so that we don't end up with problems which you have mentioned.
Okay. So my next question is, there is a belief in statistics. There is a belief that statistics focuses a lot on the behavior of the data model rather than the data and the processes that may generate it. So in short, it focuses on making the data fit the model rather than adapting the model to fit the data, which is where the algorithmic modeling culture of machine learning can come in handy. What are your opinions on this and the relationship between statistics and machine learning?
Yeah, I mean, your question is right. I don't disagree with that. But there are problems where you need statistics, and there are problems where machine learning can provide some benefits as well. So it depends on the nature of problem. And another aspect is how much data is available. So traditionally, many machine learning models, for example, neural networks and deep learning, they require a lot of data. For processing image data or video data, machine learning is very useful. But if you think about problems related to clinical trials, situations where your sample sizes are very small, events are very rare, you need statistical techniques. So it depends on what problem you are trying to solve. Each discipline has its own strengths. And another aspect which I have seen that when it comes to model interpretability, you also have to think about which technique is providing you better results. So, so if you do an analysis, the the model which you are using, humans should be able to understand. So that's another aspect, which you have to take into account when you are using a statistical or a machine learning technique. So some of the machine learning techniques, they are black box models. So what it means is that it's very difficult for humans to understand what exactly is that model which is providing certain result. So it depends on the use case which you are trying to solve, and both disciplines have their own strengths, I would say.
So last but not the least, we have noticed a trend even our batchmates even in our batchmates that the economic graduates pursue a degree in data science, sometimes even side by side. So I wanted to ask, according to you, what are the future prospects for the students with an economics background, and how should one decide if they want to pursue a combination of economics and data science?
It's a very, very good question. So when you are in economics field, right? So I know your syllabus. So I would say first, pay a lot of attention to your statistics courses. Make sure that all your concepts are clear. Okay, that is very important. So I understand you have some classes on econometrics and probability statistics, right? So make sure that you do very well in those classes. Try to understand the concepts, and at the same time, make sure that you get some certifications. Because many companies, they provide certifications in their programming languages or analytics packages. Like SAS provides certifications, like beginning the SAS developer, advanced SAS developer certifications, that I would recommend you pursue that. And then there may be other vendors also who provide this. But so programming is essential. Okay, so you cannot run away from that. So statistics, you have to be good in statistics, and you have to be good in programming. Okay, so those are the two things. And again, you can take some courses on Coursera, which are very affordable, and they are very good courses which are provided by very good instructors. Okay. So, and every course provides a certificate which you can use when you are going for a job. So I won't say that you have to pursue a degree in data analytics along with your school, along with your college courses, but pay attention to the courses which you are doing in your college, as well as you can do some certifications or do some courses online. That is very important. And I would start, I would say that start that in your first year of college. Don't wait till final year. Okay. So you need to build these credentials, that get some certifications on programming, get some certification on these courses. Along with that, pay attention to what is, because your coursework is very good. Your institute's coursework is very good. You should pay attention to those classes. And even if you do like 1 or 2 hours every day, over 3 years, you will learn a lot. And you should be able to get a very good job with your credentials. So those are the things I would say. Don't run away from programming. Okay? Don't be scared of programming. You cannot live without that if you want to go in analytics. And, as I said, try to learn some courses. There is so much material on internet. It's just you have to take time to read and understand it. And good thing is that this material is at different levels. You can have a beginner level course, you can have an intermediate level course, you can have an advanced course. So all those courses are available. So if you look at Coursera or Udemy, those sites you should go and try to do some courses. So once you do your first course, then you will get a very good idea. But start somewhere, and use all your 3 years of degree. Don't wait till the last 6 months of your final year. Start something from the first year and develop yourself over time. And another thing you should try to develop is that create your own GitHub projects. Okay, so you should look at what is a GitHub, and so basically this is like a public repository of your projects. So where you can solve some problems and upload your code there. So that gives a very good visibility to kind of work you have done. And another advantage is that nowadays, lot of data sets you need to learn certain statistical technique. They are available for free online. Okay, so now it's very easy to develop a skill provided you put in time. Okay, so that's what I would say. That try to learn something, both theoretically and the programming aspect of it, and over time develop a repository of your projects where you have demonstrated that, okay, this is the problem, this is the data I used, and this is the solution out. So that becomes a proof that you have done something. The sooner you start, better it will be.
So, sir, thank you for being with us today. It was really inspiring for me in many ways, and I'm sure it will be for our viewers. Thank you for taking out time from your busy schedule and joining us on the Coffeecontalk. It was a very insightful discussion.
No problem. All the best with your studies, okay?
Yeah.
Thank you so much.
Thank you so much.
Bye.
Bye, sir.